Hello, my name is Jaime Miranda, and today I'm going to go over how to determine total phenolics by the Folin method. Anytime you're working in the lab, you should be wearing proper PPE. This would include pants, a lab coat, goggles, and gloves. You should also collect any waste in a proper container and store it until it is time to dispose it. The principles of this method are to extract total phenolics of either juice or wine and then to measure them by spectrophotometer. The pros of the Folin method is that you can measure all mono and dihydroxylated phenolics. However, the cons are that things such as fructose and SO2 may interfere with your results, and the spent reagent is very hazardous and must be dealt with appropriately. The reagents that you will need for this lab include gallic acid, which you will have to make, Folin reagent, which is purchased and ready to go, and finally sodium carbonate, which you also will have to make. The equipment you will need for this lab includes the following: 7 10 milliliter glass tubes or similar size with the rack, 7 cuvettes that are 1 centimeter pathway, 7 100 milliliter volumetric flasks, chem wipes, Sharpie to label your glass, the gallic acid plus sodium carbonate, and 5 gallic acid standards. Our lab has a 1, 2, 5, and 10 milliliter volumetric pipette. If you can find a 3, use that. Otherwise, use the sizes 1 and 2 to make 3 milliliters. Beakers would be helpful for the waste and the reagents. A DI water bottle and dropper to finish off filling to volume the volumetric flasks. You will need micro pipettes. If you have access to maybe 2 or 3, that would be better because you will be using them at different volumes. When making the sodium carbonate, it may be a good idea to lessen the volume. For example, I did 20 grams of sodium carbonate in 100 milliliters. I made mine in a beaker with 50 milliliters of water and brought that to a boil on the hot plate with a stir rod mixing. After boiling for a few minutes, I allowed it to cool to room temperature before decanting it and transferring into a 100 milliliter volumetric flask and then filling to volume with DI water. When preparing gallic acid, use an analytical balance if you can, because you will be weighing out 0.500 grams of dry gallic acid, which will then be dissolved in 10 milliliters of ethanol and transfer into a 100 milliliter volumetric flask, then dilute to volume with DI water. This is a 5 grams per liter ratio. To prepare a serial dilution of gallic acid from the stock solution, you will need the volumetric pipettes and your volumetric flasks. It is a good idea to pour your reagent into a beaker and never pipette from your stock solution. The reason for this is that if you do not, you will contaminate your stock, which generally is very expensive and will lead to bad results in the future. Pipette a small amount to prime the volumetric pipette and dispense to a waste container. Repeat these steps for each of the volumetric pipettes. Once they are primed, make sure you fill your volumetric pipette slightly above the to dispense line, or it may be marked as TD. Stop the flow just above that, and then place your finger above the top to stop the flow. You can dispense by either lifting your thumb slightly up or rolling your thumb, whatever method works for you. Volumetric pipettes are designed to dispense the correct volume. However, if one of them has a slow flow or is not completely dispensing, you can push out the solute with the pipette bulb. Once this is complete, fill to volume with DI water and repeat these steps for all standards. You will only need a few milliliters of the Folin reagent, so I suggest putting it into a small beaker of 10 milliliters. You can do the same for the wine because it will be a very, very small amount. For your wine sample, you will micropipette 20 microliters of the wine into the glass tube. If you are analyzing a red wine, you will need to dilute by a factor of 10 prior to this step. For all glass tubes, which includes your wine sample and standards, you will need to add 1.58 milliliters of water, 100 microliters of the Folin reagent. Then you will need to mix it well and wait 8 minutes. After 8 minutes, you should add 300 microliters of sodium carbonate solution and shake to mix. Once this is done, place the rack of tubes in the 40 degrees Celsius oven for 30 minutes. While your standards and wine sample are in the oven for 30 minutes, head over to the spectrophotometer and turn it on, as it does take quite some time to start up. Once it is ready, set it at 765 nanometers. And then remove samples from the oven after they have reached their 30-minute waiting period. Transfer the whole amount into the 1.0 centimeter cuvettes. You may want to label a cuvette holder so you don't mix them up or spill them. You will set the blank first. Be sure to wipe all cuvettes down with chem wipes to remove any liquid or particles that may interfere with the reading. When placing the cuvette into the spec, make sure the arrow is pointed toward the open slot. Note the slot and press the corresponding key. Once the spec gives the reading, record the absorbance. Just as the image, you should see colors darken as concentration of the sample is higher, and after the oven, they will turn to the blue color. Now that you have all the data, perform a linear regression in Excel for the standards and use the y equals mxb formula to calculate the concentration of your wine sample. Note the formula listed in the formula bar on this image. The typical range you should see in wine include the following. Red wine should be between 1,300 and 3,000 milligrams per liter, and white wine is lower, generally ranging from 200 to 300 milligrams per liter.